All right, so today again we're gonna have some examples related to the level of service, and we discussed again three types of facilities that were interested as traffic engineers to obtain the level of service, and those are freeways, multi-lane highways, and two-lane highways. So let's go to your textbook. I hope everyone have access to it by now. Can everyone see the textbook that I'm sharing?
Yes.
All
Yes,
right.
sir.
Okay.
Sure.
Let's get going with this. So we have here example 6.3. It's a multi-lane highway, and we're getting the free flow speed off of that. Let me see here. In fact, you know what? Let's start with example 6.1 for freeways. All right, so this is basic freeway segment level of service. So we're gonna start with this example here, example 6.1, and let us take a picture of that. Oops. And just do the example by ourselves instead of just looking at the answer. Stop the share again, the notebook. Okay. If you don't see that the note here, then let me know. I assume that you can see it. Example 6.1. This is here. So example 6.1, and we need to get the level of service for a freeway. So it's a six lane urban freeway. Why do we need to know 6 lanes, which is 3 lanes per direction? Because again, that's gonna help us to get the correction factors for the free flow speed. So it's a 6 lane urban freeway on a rolling terrain, and that is also important, with an 11 feet wide lanes, obstructions of 2 feet from the right edge of the traveled pavement. That's also important. If you recall, this is gonna govern for us the lateral clearance, and 9 ramps within 3 miles upstream and 3 miles downstream of the midpoint of the analysis segment. The traffic stream consists primarily of commuters. This is also important. If you recall again, this is the FNP, the uh, the number of population that are familiar with the freeways. Are we having majority of people familiar with the freeway? Therefore, your experience is going to be way better because everyone is aware of all the ups and downs and left and rights in this freeway. Or do we have significant amount of people who are this is their first time to use the freeway? That's going to make a big difference, and that's why here once we say primarily for commuters, that means again FNP is going to be approaching 1. We have a directional weekday peak hour volume. This is the volume of 2,300 vehicles. We're going to use this to get the VP, if you recall. And with 700 vehicles arriving in the most the congested 15 minute. Why do we care about this highest 15 minutes? This is what we're gonna use to get the peak hour factor. Remember, the peak hour factor is equal to capital V, the volume, in the full hour, over V15 times 4. V15, this is the flow rate in the worst 15 minutes within that peak hour, and that is in this case 700. If the traffic stream has 15% large trucks and buses and no recreational vehicles, determine the level of service. All right, so this is basically what it is. We need to get the level of service given all this information. If you recall, and so many of you will skip that, is we need to, before you go through the calculation, you need to check all the base conditions. And if you satisfy all of them, then it's a level of service A and you don't need to do any calculations. But if you recall, just by looking at the very first line here, we're having 11 feet lanes. And if you recall, the the minimum lane width for freeway is what? You guys remember? So it's actually not 12, it's actually 11. First I can do. Thank you. It's 11. It has to be 12 feet. So the 12 feet, that's the minimum. So once we have now 11 feet, we know that we're deviating from the base condition, and therefore we are actually we need to do the calculations because now we're deviating from the base condition. So let's get going with the next step. If once you are not satisfying any of the base condition, now you need to go through the calculations of both the free flow speed and the VP, which is the flow. So once you get these two, we can go now to the graph, if you recall, of having the level of service. This is here the FFS and the y-axis and VP on the x-axis. This is how can we get the level of service. So let's get going with the FFS. So the FFS, the equation for the FFS is 75.4 minus FLW minus FLC minus 3.22 TRD to the power 0.84. All right. Let's get going now with the first correction, FLW. This is for the lane width. For the lane width, I need to go to the table, and that is table 6.3 in your textbook. This is your table 6.3. So if you go to the table 6.3, and I have the book here, and I hope you have the books with you. So table 6.3 in your textbook, if the lane width is 12 feet, the correction is 0. If it's 11, like in our case, the correction is 1.9. So FLW from table 6.3 is actually 1.9. And the units here are in miles per hour. That's the first correction. Next is FLC. FLC, this is actually for the lateral clearance correction. For FLC, you need to go to table 6.4. This is table 6.4 to obtain the value. So if we go again to your textbook for table 6.4, and it's going to ask you now for the right shoulder lateral clearance, and it was given to us. If you notice here, this is the 2 feet. This is the obstruction from the right side. So we only have 2 feet worth of shoulder. So that is 2 feet. And then we have 3 lanes per direction. So it's going to be 1.6. So the table actually for 6.4 depends on how many lanes per direction and what's the right shoulder width. So if you match these two, you're gonna get the reduction. It happened to be here is 1.6 miles per hour. Next is the TRD. This is the number of, again, ramps, on and off ramps, and there was an equation for it. So TRD, if you recall, again, it's the number of exits over 6 miles. So we have 9. Where did we get the 9? It's actually right here. So we have 9 ramps within 3 miles upstream and 3 miles downstream. So 9 over 6, that's going to be equal to 1.5 ramps per mile. So once we have all these numbers, now we can obtain the free flow speed. The free flow speed, therefore, is equal to the 75.4 minus 1.9 minus 1.6 minus 3.22 times TRD, which is 1.5 to the power 0.84. And it's a simple math here, and that will be equal to 67.4 miles per hour. Typically, for free flow speed, we round it to the nearest 5 miles per hour, but we round it to the lower number just as a factor of safety. You cannot say the free flow speed is 70. But we round it to the nearest lower 5, so that's going to be 65 miles per hour. That will be the free flow speed. Next, we need now to get the VP. Remember, this was so the very first point, the very first step is to check the base condition, and then the second step we need to get the free flow speed, and then the third step we need to get the VP. So then we need to get the determine the flow rate according again to equation 6.3 in your textbook. So VP, if you recall again, it's capital V, the volume in 1 full hour, over PHF, the peak hour factor, times N number of lanes per direction, times FHV, the heavy vehicle adjustment factor, times FP, the population factor. So the V is easy. The V, we know the V is 2300. Where did we get this from? It was provided to us in the example. So here, the directional weekday peak hour volume, the volume is 23 vehicles, and the worst 15 minutes is 700. So again, we're gonna need this for the peak hour factor. The peak hour factor, if you recall again, peak hour factor, it's the V, which is 2300 over the worst 15 minutes, which was 700 times 4. That's the peak hour factor. Times N, this is number of lanes per direction. That's a common mistake here. You need to include the number of lanes per direction, not not the total number of lanes. Remember, for level of service for freeways and multi-lane highways, we obtain the level of service per the direction. Sometimes we have a level of service in the eastbound, A, and level of service in the westbound, C. It's different than when we're doing the two-lane highways, where the two lanes now are just one lane per direction and they're highly correlatable. But for freeways and multi-lane highways, we do it per direction. So a number of lanes here is 3 times FHV. So we need to calculate FHV. So FHV, and again, if you recall, we've done that last time. FHV, the equation for FHV is equal to 1 over, and just do the equation. Now I'll give you the equation number. So it's equation 6.5 in your textbook. 1 over 1 plus PT times ET minus 1. And again, these equations will be provided to you. If I don't remember them, as you could see, I'm writing them from the textbook. I'm not expecting you to know them. So plus PR times ER minus 1. All right. Where do we get all these numbers? So the PT and the PR, those are the proportions. Those are the percentage of trucks and buses, and PR, the percentage of recreational vehicles, RVs. So those were given to us in the problem. So PT is 15%, and PR is 0. There is no recreational vehicles on this highway or freeway. So that is known. So PT is 0.15, and PR is 0. So therefore the whole thing is 0. So we need to get the ET. Where do we get the ET? ET, we get it from the table. ET from table 6.5. Table 6.5. And that is basically, it's a small table. It depends on the level, again, the type of terrain on this freeway. Is it level terrain, rolling terrain, or mountainous? and we were told it's a rolling terrain, and therefore ET in this case, based on table 6.5, is 2.5. So ET is equal to 2.5, 2.5, and therefore FHV is actually now equal to 1 over 1 plus 0.15 times ET, which is 2.5, minus 1. And therefore FHV is equal to 0.816. All right. So if you recall here, coming back to the VP, we have the total volume, which is 2300 over the PHV, PHF. That's the peak hour factor, 2300 over 700 times 4 times 3 lanes per direction times FHV, which is 0.816 times FP. FP again, this is the population factor, and since we were told that the majority of the people using such freeway are commuters, therefore FP is equal to 1.0. So I'm gonna go back here to this equation times 1.0, and therefore VP is equal to 1145 passenger cars per hour per lane. Really, what we're doing here, this is a conversion factor of all the trucks within the worst 15 minutes and the peak hour equivalency to get to this number, which is 1145 passenger cars per hour per lane. Once we get these two numbers, which is the free flow speed is 65 miles per hour and the VP is 1145, now we can go to the graph that I showed it to you before, and that is figure 6.4 to get the level of service. So really now what we need to do, let's go back to the textbook to check our numbers first. So the free flow speed again is 75.4 times minus FLW minus FLC times 3.22 TRD. We've gone through that calculation. We have the free flow speed again. Calculation wise, it was 67.4, but we rounded down to 65, and then we needed to get the VP. The VP again, to get the VP, we need to have the PHF and the FHV. So we've gone through that part of calculations. So we get 1145. So now we need to go now to figure 6.4 in your textbook. Is that the right one? No, actually it's figure 6.2. My bad. 6.2. 6.4 is for multi-lane highway. See? You need to be familiar with those. Uh, yes, there we go. So the good thing again, when I'll provide all these figures to you in the exam, and I'm not gonna be too tricky to remove the name of the figure. So you need to read it though. So it's a basic freeway segment curve. So let's see how can we use this one. So we have the speed is the free flow speed that we determined is actually 65 miles per hour. So again, it's gonna be around here. So we're gonna pick that line, 65 miles per hour, and the VP, which is on the x-axis, is about 1145. So you know what? To make this fun, I'll take a picture of that and take it back to our node All right, so we have our numbers and we're gonna paste it here. There you go. Okay, so we have 65 miles per hour right here. So we can draw a horizontal line and the VP, which is the flow rate, it was 1145. So this is 1,000 and this is 1,500. So roughly somewhere here, we're gonna draw a vertical line. And where the 2 points meet, this is now the area for the, so where you get the level of service. So level of service A is anything in this area. Level of service B is between the two lines, between this line and this line. So apparently we have a level of service B. Or some of you also may actually do the math and even use the numbers on these lines. So if I have a density here more less or equal to 11 passenger cars per mile per hour, that's the level of service A. If it's somewhere between 11 and 18, it's the level of service B. So how can you get the density? It's simple. The density is actually VP over FFS. So VP is 1145 over the density over the free flow speed 65, and therefore the density is actually 17.6 passenger cars per mile per hour. So it's almost borderline, but it's again, it's 18 or less, therefore it's the level of service B. So either or, you can just connect the dots between the free flow speed and the flow rate and obtain it like here, and that would be level of service B for this triangle. Anything within this triangle is level of service B. Or if you want to be more accurate and just double check, just divide the flow rate over the FFS, the free flow speed, and get the density 17.6. And again, these lines, for example, again, level of service C is somewhere between density between 18 and 26. That's level of service C. Anything between 11 to 18, that's level of service B. And therefore, you get the level of service for this field, which is equal to B. Any question on example 6.1? All right. We're going to shift now to example 6.3 in your textbook again. So going back to here, and now let's go to example 6.3, and that would be for multi-lane highways. That is 6.1. All right, we are here. Example 6.3, this is now for multi-lane highway. It's a little different, yet similar to freeways. But again, as I mentioned in the recorded lectures, you need to make, again, judgment of what graphs are you using, what tables are you using, because some of them are similar, some of them are not. So let's take again, let's read the example, and then we're going to go through the notes and do it ourselves. So example 6.3, it's a 4-lane undivided highway, which means it's 2 lanes per direction, and it has 11 feet lanes width and a 4 feet shoulders on the right side. There are 7 access points per mile, and the posted speed limit is 50 miles per hour. What is the estimated free flow speed? So here in this example is not really interested in all the way to the level of service. Sometimes I do that in the exam too. I don't have time to ask you for like 10 questions. I can ask you for half of the process. Give me just the free flow speed. And some of you, again, if you don't read the question, you're just gonna you get going and you're gonna get the free flow speed, the VP, the level of service, but you're gonna be consuming a lot of time and not doing the rest of the exam properly. So be aware of what I'm asking you. So here, this is a great example where I'm just asking for what is the free flow speed for this multi-lane highway. So for the free flow speed, we're gonna do the example. So let's first take again a screenshot of it and go note taking. And let's start another example here. This is example 6.6.3. Let's paste it here. All right. It's a 4-lane undivided highway. So first, what's the equation for the free flow speed? So free flow speed for multi-lane highways is a little bit different. If you recall again, and please, you need to watch the recorded lectures before you can follow up with these examples. Otherwise, again, there will be something missing here. So free flow speed is basically the free flow speed at the base condition minus FLW, correction factor for lane width, minus FLC, which is correction factor for lateral clearance from the two directions this time, minus FM, which is how many access points, minus FA. All right, so let's get going here. So the BFFX, that's the very first thing. How can you obtain the BFFS? It's either it can be provided to you, or if it's not, that's not provided to you, as I mentioned in the recorded lecture, it's basically the BFFS is the posted speed limit plus 5 miles per hour. So it's the posted speed limit plus 5 miles per hour. So the BFFS therefore is equal to 50 plus 5, and that would be 55 miles per hour. That's the first step. Then FLW. This is now the lane width correction. FLW is actually the same table as the freeways. See, again, there are some similarities and some differences. For FLW, it's the same table that you use for freeways, which is table 6.3. If you go to table 6.3, again, 6.3, it's actually same thing here. We have an 11 feet, if I'm not mistaken, so 11 feet lane width. Therefore, the FLW is 1.9. So FLW is equal to 1.9 miles per hour. All right. How about FLC? FLC is different because now this is for the lateral clearance for multi-lane highways. We're going to use a different table. This is table 6.11. Table 6.11. And for table 6.11, I hope you have it in front of you. Where it asks for what's the total lateral clearance, and then whether it's a 4-lane highway or a 6-lane highway. For our case, as is mentioned here, it's the 4-lane highway. So we're going to use the first column. And then the total lateral clearance. In this case, how can we get the total lateral clearance? So the total lateral clearance. Lateral clearance. If you recall, again, if we have here a multi-lane highway, we need to measure the lateral clearance from both sides. From the right side, it's what's given to us already, which is 4 feet. That is here, that is 4 feet. From the left side, it's not given to us because it says actually that it's undivided. If it's undivided, by default, we need to have 6 feet from between the two sides. So that's again, please take note of that. If it's undivided, that means again they are undivided. But we have to have, if it's undivided, we have to have a minimum of 6 feet between the two directions. So really here, the lateral clearance calculation is going to be 6 plus 4, and that would be 10 feet. And if you recall again the recorded lecture, if you have anything more than 6, you only take 6 into that equation. So 6 plus 4, in this case, again, because none of them is more than 6, so we're taking the full 6 from here, and we're taking the full 4 from here. And that's why we have 6 plus 4, that's 10 feet. So you go back again to table 6.11 and you find the 10 feet, and for 4 lane highways, that is going to be zero point 0.4, the FLC. Therefore, FLC is going to be equal to zero point 0.4 miles per hour. Miles per hour. All right. So we got the FLC and we got the FLW. Then we're going to now do the FM and FA. FM from table 6.12. This is whether we have a median or not, and FA is actually the axis points. I'll take that back. So FA, this has to do with axis points. FM, the median correction factor. So FM is actually, we get it from table 6.12. So really here it's a very simple table. And it has two options, whether it's undivided highway or divided highway. If it's divided, there is no correction factor. FM is equal to 0. If it's undivided, like in our case, the reduction will be 1.6. FM will be 1.6 miles per hour. Constantly, 1.6. All right. How about FA? The last thing here to get done with this problem. FA, has to do with axis points, which we covered again in the recorded lecture. So this is, we obtained this correction factor from table 6.13. And we do have here, how many axis points? We have 7 axis points. So on the table, it says axis points per mile and versus the reduction. So I'm gonna here, so we have number of axis points per mile, and this is the reduction factor, which is actually, this is the FA. If we have 0, 10, 20, 30, and more than 40. The 0 is 0, of course. If you have no axis points, there is no reduction. If you have 10, it's going to be 2.5. If you have 20, it's going to be 5. If you have 30, that's 7.5. Anything more than 40, that is 10. In your case, we have here 7 axis points, so it's going to be somewhere in between, where we have 7 here. So you need to do a simple interpolation. And this is linear relationship. So really what you can say is, if I have 10 axis points, the reduction is 2.5. How much is that if it's 7? So it's going to be 2.5 times 7 over 10. And that would be 1.75. That's the correction factor for the number of axis points. So once I have all that, now I can get back to my equation here. The FFS is equal to the BFFS, which is 55 miles per hour, minus 1.9, and that is FLW, minus 0.4, that's FLC, minus 1.6, and this is FM, minus 1.75, 1.75, and this is FA. So really here, the total answer after all that is 49.35 miles per hour. That is the FFS. This is the free flow speed, for this location. Roughly here again, you're gonna ask me what's the correction factor. It's tough here because it's very close to 50. So typically, as the textbook suggesting, we leave it at 50 miles per hour. It's gonna be too much conservative um, correction if we truncate it at 45 miles per hour. So typically, again, if it's very close or almost there, so it's 5 miles per hour. 50, I mean 55, 50 miles per hour. Any questions on this example? Questions, concerns? All right. Let's keep marching on now. The next example, example 6.4. This is now how can we get the level of service for a multi-lane highway. So last example, we just stopped at obtaining the free flow speed. Now we're going to be getting the the uh, the level of service for that structure. So let's go back to the textbook and get the example 6.4. So the example 6.4 is a multi-lane highway, and we need to get level of service for that. So it's a 6-lane divided highway, which means 3 lanes per direction, and on a rolling terrain with 2 access points per mile, and it has 10 feet lanes, significantly narrower than the base condition. So by the time you're reading the question, you're actually doing the first step, which is checking the base condition. And if you satisfy it, awesome, because now it's level of service A and you don't need to do any calculation. But just by reading carefully through the problem, you notice that it's 10 feet per mile, 10 feet lanes, which is far away from the base condition, which is 12 feet. And therefore, you're going to know you're going to go through the calculations of free flow speed, the VP, the density, all the way to the graph. All right. With a 5 feet shoulder on the right side and 3 feet shoulder on the left side. The peak hour factor is 0.8. So it's given to you. You don't have to calculate it this time. And the directional peak hour volume is 3,000 vehicles per hour. There are 6% large trucks, 2% buses, 2% RVs. There is a significant percentage of non-familiar roadway users, and they are in the traffic stream. And therefore, here we're giving you that the driver population adjustment factor is not 1 anymore, it's 0.95. There is no speed studies are available, but the posted speed limit is 55 miles per hour. Determine the level of service. Very classical question um, that you can see in an interview, you can see in the FE or PE exam related to the level of service. So let's take a screenshot of that and do this example. All right. Let's stop this here. Again. And let's start a new example. This is example 6.4. Let's click here. Can everyone see what?
Yes.
Yes.
Thank you, guys. Thank you. Sometimes I can shifting between couple screens. I just want to make sure. Okay, so here we have the example, and we need to apparently again go through the steps. Just for formality, actually, the first step, step 1, is actually to check the base condition. So the base conditions, again, you have 10 feet lane, so we're not satisfying that. So I know from now it's not going to be level of service A, and I have to go through the calculation. So I need to get the free flow speed as a second step. I need to get the VP as a third step, and eventually I need to get the density, which is going to lead me to the level of service. So I hope, again, we're agreeing on those the steps at least. So let's get the free flow speed. The free flow speed, we just did it. We're going to just repeat it. So the more the better. The more practice, the better. So BFFS minus FLW minus FLC minus FM minus FA. BFFS, again, is the posted speed limit plus 5. So the posted speed limit here is, it was, so the posted posted speed limit plus 5. And therefore it's 55 plus 5, that is 60 miles per hour. Then FLW, again, it's table 6.3, if I'm not mistaken. Yes, yeah, table 6.3. Now, when you go to table 6.3, you need to pick the right number because now the lane width is significantly lower. Lane width now is 10 feet, not 11. So the correction factor, which is FLW, is equal to 6.6 miles per hour. Huge difference between having an 11 feet lane compared to 10 feet lane. And of course, compared to the 12. So the 12, there is no correction. 11 is very small correction because now once you reduce the width by 1 feet, maybe again, your experience as a driver is going to be, again, not as good as 12 feet, but the reduction is roughly 1.9 miles per hour. But once now we reduce it by 2 feet from the base condition, now you're going to feel it's so tight and your speed now, the free flow speed would significantly be lower by 6.6 miles per hour. So that's table 6.3. FLC, the lateral clearance, where first we need to know again which table, and again, like what we did last time, for example, 6.3, we need to use table 6.11. And if you go to 6.11, to get to table 6.11, we need to get the total lateral clearance from the right and the left. So going back to the question, it was told to us that we have 5 feet shoulder from the right and 3 feet shoulder from the left. So really the total lateral clearance is equal to 5 plus 3, and that is equal to 8. So when you go now to table 6.11, you're going to go to 8, and it's how many lanes per direction? It's a 3 lane per direction. So the correction factor is 0.9. FLC, sorry, is 0.9 miles per hour from table 6.11. All right. Now FM is actually table 6.12. This is a simple table, as I told you in example 6.3. It's either divided or undivided. In this case, actually, it's a divided highway. So the correction factor is 0 here. So based on table 6.12, is the correction factor for FM is equal to 0 miles per hour. And then FA, this is table 6.13. And we have how many here? Two access points. Only 2 access points per mile. Very, very little. So again, using table 6.3, if I have 10 access points, I'm going to have a reduction of 2.5. If I have 2, how much is that? So 2.5 times 2 over 10. And that's again going to get me to 0.5. 0.5 miles per hour. So I got all the numbers, so I can get back now to the FFS calculation. FFS is now simply equal to 60 miles per hour, which is the free flow speed at the base condition, minus FLW, which is 6.6 miles per hour, minus FLC, and that was 0.9. Yes, right here. So that's 0.9 minus FM, which is 0, minus FA, and that was 0.5. And therefore, the free flow speed is 52 miles per hour. And what do we do again? We round it down to the nearest 5, and therefore that's going to be 50 miles per hour. The free flow speed. So that's the second step. We got the free flow speed. Now we need to get the VP. The VP is equal to capital V over the peak hour factor times n number of lanes per direction times FHV, this is the heavy vehicle adjustment factor, times FP, the population factor. Some of those are straightforward, and only one in this case is actually we need to calculate it. The capital V, this is the total volume, which is 3,000 vehicles per hour. That is 3,000 over PHF. This time we don't need to calculate because it's given to us. The peak hour factor is 0.8 times N. In this case, N is equal to 3 lanes per direction times FHV. This is what we need to calculate times FP. Again, big percentage of the people who are using the facility actually are non-familiar users. So that's why it was given to us that FP is equal to 0.95. So really what's missing is FHV. And that's what we need to calculate. FHV, again, same equation, and that's equation 6.5. Go back to your textbook, and I'm going to go back to, so that is equal to 1 over 1 plus PT times ET minus 1 plus PR times ER minus 1. So where do we get all these? It's equal to 1 plus PT. This is the percentage of buses and trucks. So let's go here to the question. So there were 6% large trucks and 2% buses. So we need to sum these two up. So 6% and 2%, that's 8%. So that's actually 0.08 times ET. We need to get it from a table, but let's keep it for now. Plus PR. PR, this is the percentage of RVs. And in this example, we have some percentage, which is 2%. That is, so the 0.02. The percentages here, as you could see, they are in decimals. So 0.02 times ER minus 1. All right, so where do we get the ET and ER? We get the ET and we get the ER from table 6.5. So table 6.5, very simple table. It only asks for what type of terrain you have. Is it level or rolling or mountainous terrain? And let's go back to here. We have a rolling terrain, and that will be the middle column in that table. So for ET, using that table, ET will be equal to 2.5, and the same table will also provide you ER equal to 2. So if you replace these two numbers, FHV actually will be equal to 1 over 1 plus 0.08 times 2.5 minus 1 plus 0.02 times 2 minus 1. And this whole number here is going to be equal to 0.877. Don't be lost in calculations. We are not done yet. So FHV are going to go back to here, the VP. Now FHV is equal to 0.877. And everything else was known. So the VP is equal to 1,500.3 passenger cars per hour per lane. That's the VP. Why do we need the VP again? Going back. So we need to get the VP in order to get the level of service. Now we need to use actually the different graph to get to level of service. That's going to be figure 6.4. Figure 6.4. And again, it reads multi-lane highway. And now we're gonna use the two numbers that we got, the free flow speed as well as the VP. So the free flow speed FFS is equal to 50 miles per hour, and the VP is equal to 1500 passenger cars per hour per lane. So let's go to that graph in your textbook to get the level of service. All right, so going, and that graph is page 195. So there you go. So table, figure 6.4, as it reads here, it's multi-lane highway, free flow speed determination. It's not for freeway, it's multi-lane highway. So let's take a screenshot of that. And going back to our notes and paste it here. All right. So how can we get the free flow speed? Again, there are two ways using this simple graph. We can draw it. So free flow speed 50. So this is the line here for 50. And VP is in the x-axis, 1500. And therefore it's going to be right here, and that's going to be level of service D, level of service D. Or you can say, no, I want to get the density. The density is equal to 1500 over 50. That's very simple. Theory, that's the density is equal to 30. So any density between 26 and 35, which is almost in the middle, that's D is equal to 30. Therefore, that's another confirmation. That's the level of service D. Level of service D. Any question on that problem? All right, I think I'm gonna stop right here for the level of service for two-lane highway. I'm gonna ask you again to go to that recorded lecture of one of my colleagues at Iowa State that I posted. It's gonna be the same thing. Typically, again, it's a long example, so it's not gonna take us just 15 minutes or so. But just for continuity's sake, I want you to go through the example this weekend, or actually this week. And before we meet next time, if you have questions about two-lane highway level of service, we can go through it next time. If not, we're gonna march on with the next chapter. Any questions, though, on the examples that we covered today?
Sir, not for me.
Right. Sounds good. So I think I'll stop right here. And again, I'll have the recorded lecture for Thursday, and I will guys again live on Zoom next week. Thank you so much.
Thank you.
Thank you.